Okay, so problem 37, we have a core that's 25 centimeters long. It weighs 15 grams. That means it has a mass per unit length of 0.015 kilograms per 0.015 kilograms per per 0.25 meters. Okay. 0.015 divided by 0.25 is 0.06. 0.06 kilograms per meter. That's its linear density. It's initially stuck to the ceiling and then it hangs down vertically. And so when it's hanging down, if we look at a little piece of it that's DH or DL, right? DL in size, and we call the distance from the ceiling L, which will go from 0 to minus 0.25 meters, right? 0 to minus 0.25 meters. Then what is the potential energy of this little segment dl? Well, what's its mass? Its mass is mu dl. Right? Its mass is mu dl. So that's the mass. Put in gravity and put in L. Does that make sense? Right? And now we want to sum all of these up, which really means just doing an integral. Okay, so we have our little mu dl is our mass, right? So I'll write this as a little dm, little differential piece of mass is mu dl. And so a little bitty piece of potential energy is mu times g times L times dl. All right, mu g L dl. And now if we want to know the total potential energy, it's the integral from 0 to minus 0.25 int 0 to minus 0.25, and that's meters of mu g L dl. Okay, integral of L dl is just 1/2 L squared. So we've got U equals 1/2 mu g L squared evaluated from 0 to minus 0.25 equals 1/2 mu g times 0.25 squared. Okay, put in all the numbers, equals 1/2 times 0.06 times 9.8 times 0.25 squared is 0.018 joules. 0.018 joules. And that would be our average potential energy. Okay, so now that we've had, however, now that we've had the chapter 9 lecture, we also know we could just treat this as a point particle at its center of mass, right? Okay, so we could treat this as a point particle at its center of mass, and you know, I think I need a minus sign in here somewhere. Oh, I probably need a minus sign in the integral because we're going to integrate from minus 0.25 to 0. And that's going to give us 0 minus 0.25, and that's going to introduce a minus sign here. Minus. Okay, now given the chapter 9 lesson, right, this is what we have now is minus 0.018 joules of energy relative to where we started, which was this piece of spaghetti stuck to the ceiling instead of dangling down. Okay, now given the chapter 9 lecture, we can treat this as a point particle at its center of mass. And where's its center of mass? Well, it's down at 1/2 of 0.25 meters, right? Times the total mass, 0.015 kilograms, right? So we can treat it as 0.015 kilograms dangling down at half of its length. And if we do that, what do we get for an answer? We get minus 0.5, well, minus 0.5 times 0.25 times 0.015, and we get 0.25, what did I do here? 0.25, yes, times, I forgot the 9.88 times 9.8, and we get the same thing, minus 0.018 joules. So chapter 9 makes this a little easier to conceptualize than going through this integral. And that's it, problem 37.